Today I'm going to talk about a probability question, a very interesting probability question that sort of explains why gambling is pretty bad. It's unfavorable in probabilistic terms. So I'm going to set up a scenario that mimics the scenario in the casino, but obviously it's a simplified model, so it's not going to fully represent the situation. So let's assume a person went into a casino and he has $1,000 first. He wants to win $1,000, so that's his objective. So when he wins $1,000, he will leave the casino. And in this casino, the rule is that after each round, you can either win or lose $1,000. So there's also a probability that he's going to lose all of his money. So actually, if he loses all his money, then he cannot gamble anymore. And at this state, he's at the state of bankruptcy. So the objective of this question or this problem or this discussion is to evaluate what the probability of him going bankrupt is. So first of all, let's assume that this person, after how many rounds of, let's say A rounds of gambling, he has, let's say $1,000 left. So at this state, let's define a variable AL. So this is the probability of him going bankrupt if he has $1,000. So what we want to find is what AM is. So this is what we want to find. So this probability has two possibilities. The first possibility is that after the person gambles the first round, he wins the first round, and the other probability is he loses the first round. So he wins the first round, and he loses the first round. So if he wins the first round, by the way, winning the first round means winning and losing have like the same probability. So both of them are 50%. So it's a half. But then remember, we're trying to find the probability of him going bankrupt. So after winning, he will gain $1,000. So at that state, he will have L plus $1,000. So that's the new probability. And this is the same concept. If he loses, then he loses $1,000. Then AL minus 1. And if you look at this sequence closely, this is actually an arithmetic sequence. Because for an arithmetic sequence, if you add the smallest term and the largest term together for 3 terms, then if you average them, it will always be the middle term, because there's the common difference property of the sequence. After knowing that this is an arithmetic sequence, the problem will be much easier. We first have to determine the initial values, or like the fixed values. So we know that if L is equal to 0, so if he has like $0, the probability is 1 because he has already go bankrupt. A0 is 1, so if he has $0, and if he already gains or wins the $1,000, so M plus N, then the probability will be 0 because he will leave the casino as he has already achieved his objective. So what happens here is, since this is an arithmetic sequence, we want to find the common difference first, and then we can find AL. So the common difference first is so it's always the y value divided by the x value, so 0 minus 1 divided by n plus n minus 0, so n plus n. But this is like each subsequent, this is like the common difference of this sequence. And what happens is we're gonna add this term, so this is like a0, so 1 plus al is equal to 1 plus k amount of common difference, so 1 plus negative k times m plus n. So the probability is going to be this. So this is the probability of al. And since we're finding the probability that he will go bankrupt at $1,000, then we just substitute, sorry, not k, l. We want to find the value when l is equal to m. So we substitute that in, then we'll see that am is equal to m plus n minus m plus n. This cancels out, so n divided by m plus n. This is our final probability. And I'm going to talk about why this probability is sort of significant. So if you graph this m plus n over m plus n, you'll see that, so let's say m is a fixed value. So
it's 11 o'clock.
If m is a fixed value, then as n increases, so if you want to gain more money, then the probability of you going bankrupt is higher. So let's actually try some values. So let's say if you have $5,000 at first. So if you want to gain, let's say, $1,000, then you will have 1 divided by 5 plus 1. So this is the probability of you going bankrupt if you only want to gain $1,000. But if you want to gain more, let's say $10,000, then your probability of going bankrupt is 2 over 3, which is like significantly higher than this. If you want to convert the denominator, it's like 4 over 6, so it's like actually 4 times of you wanting to gain $1,000. And given the nature of human greed, usually you always want to earn more and more. And as this desire sort of like develops, then the probability of you going bankrupt or losing all of your money like becomes higher and higher. So that's a very interesting math problem. That's sort of applicable to real life. And I hope all of you guys please don't gamble, because that's bad and not good in terms of probability. So see you in the next video.